Okay, let's do a little bit more today. This is the same day as my last video, and I'm super tired, but I want to get a little bit done before I call it a day. I think this video will be a little bit shorter. Um, and what we're going to do is just get some of our own types in place, our own assert, kind of start our standard library package and our naming scheme and a few of those things. One of the purposes of this whole project is for me to be able to do stuff from scratch. And a perfect example of that is one thing I'm not going to do here because I don't think I can do it from scratch right now. Is this? I basically do a memory allocator pattern that I essentially stole from the book C Implementations and Designs, I think it's called, that I read years ago. And it's a cool pattern. I've used it in a bunch of product projects where you could have a debug allocator, your normal allocator, and the debug allocator keeps track of a bunch of stuff for you by putting a header in front of the allocation. And I've used it over and over, and I've modified it throughout the projects to add additional debug stuff to it. It's super nice. And I have it in other projects, obviously on this computer, but I can't, I don't know if I can, I'm almost certain without studying a bit more and I can build it just from scratch. And I want to be able to, because I feel like if I can't, that I don't really understand it because it's not that complicated. It's really not that complicated. But I think, yeah, I want to study it a bit more before I just struggle on camera to build it myself because I've just gotten the habit of copying it over. And when you're just reading code, you're like, yeah, it totally makes sense. That's perfect. But on a blank slate, it's a little bit different because I'm also wrapping it in um, some macros because you're swapping out the implementation and tracking all the allocations and the debug allocator. The normal just heap allocator is using malloc and free and kind of ignoring all the other data or all the other parameters. And it's just using function pointers essentially. But yeah, so anyway, one of the things that we're going to do in our standard library in all of our code is anywhere that we're going to allocate, we're going to pass the allocator kind of just as the first parameter. And just, I feel like I don't use Zig that much. Actually, I don't really use it at all, but I follow it. And I do really like that pattern. And since this is our fun project, we can do whatever we want. We're going to do it. I think it should work. We'll just pass it through. If it gets too explicit, we'll kind of see. But I think it'll force us to reduce allocations and so on and so forth. So I guess the point is I'm going to work today until I get to the allocator stuff because I'm tired today and I just don't think I'll be able to do it from scratch and I don't want to bore you. So I'm going to build up kind of to that point. And once we have that, then we can dive deeper and deeper. I guess I explained it all because we might run into some places where we'll need it. I know it's going to come up and I just wanted to explain why I wasn't going to implement it today because I don't want to struggle on camera for 30 minutes. All right, so let's go. Uh, let's actually make clean, make build, make run just to see where we left off. Okay. One of the things we're going to do is let's just go ahead and make a source directory for everything. Git move to source. We're just using git move. So it tracks the move through history. So it should anyway to pick it up since there's no changes in the file, but it's just good habit. I think the make file now, it will probably sources. I think, is that going to work? Nope. Source. Oh, is it because we're not making a source directory? This is going to be an issue later, as we start having more and more directories. But for now, we're just going to get past it. I think the problem is there's no source directory for main to be put in, the main object in the build directory. So we're just going to manually do it. We don't really care right now. We'll come up with a better solution later. Okay. The reason we're putting it in there into a source directory is because we're going to start having folders and stuff pretty quick. They're on right now, actually. So in source, we're going to have different modules like a graphics module, kind of like libraries. Graphics module, it'll be GFX, and then everything in there will be prefixed with GFX. WS for like a Windows server, and the window manager and all the display stuff can be managed in there. An OS module, and everything is prefixed with OS. Just short ones. I like to name things long, except for prefixes in C because they're everywhere. But one of them that we do where we don't prefix them, one of the modules is the standard library, because you don't want to prefix strings and everything with your standard library prefix all over the place because you just use them too often. And we're gonna name my name's Adam, and as a homage to Serenity OS and Ladybird, we're gonna do AK for Adam's kit. I think his is Andreas's kit, but this will be the one little homage because it was a big motivating thing or inspirational thing is those projects for me to do this one. So and actually using C instead of C++. I don't really like C++ that much, and I'm not that good at it. But I figured if I use C++, I would end up copying. I would be too tempted to copy the implementations and stuff from Ladybird, or sorry, not Ladybird, from Serenity. So picking a different language kind of forces us to do our own thing. So, all right, I'll shut up now. Let's get to coding. I don't know if this is at Pragma is actually technically C99 instead of doing header guards, but we don't really care right now. That's easy to change later, and it's just quicker and cleaner. We're actually just going to have all of our own types for the fixed width integers, and I guess for our floats as well. This is going to be a boring amount of typing. So we're just going to do it like that. Tons of languages have this now, and it just shortens function signatures and just keeps the code a little bit, I think, less messy. We actually, I was going to say we're not going to need 64 for a while, but we might as well just do it. Who cares? For like time and stuff, we might need it. Unsigned, signed, type def. Okay, let's leave it there. You can do quite a bit more. You can do byte, and some people do size, like U size instead of size T. But I'm not going to do that just yet. Let's just keep it as simple for just now. One thing I wanted to do this project, I always like to try something new just to see if I like it. Um, I don't know, maybe it's just from Soding or somebody. I don't know where I saw it, but defining unused, and then just a little macro. Just I don't know. I don't mind the void, but it's just a fun little explicit thing. We're just going to try it out, see if we like it. Um, and the case for that is right here in our main. Right here, you could use unused. Uh, we're going to hit a couple things here because we want to always include from the root of our project, like this, type def. But, well, let's see if we'll wait till it blows up later. Let's just use the unused thing and see what happens. I'm actually going to be surprised if this works because, oh, it's because we're in the same. It'll have, basically, I want to be able to always include from the root being source like AK or GFX or OS. But it's going to blow up once we're inside one of those directories because there's nothing that's telling the compiler to look in the source directory. This just works because we're a peer to it. Like main is a peer to AK, so it can just go to AK/types. But it's a loophole for now. We get the luck out on, and we'll deal with it later when it becomes a problem. Oh, it's a very simple fix in the make file. So, uh, okay, everything's fine. Let's replace all that. Do we use an int anywhere? Anywhere we use an int, that's um, I32, and just for consistency. I don't always. I don't actually know if I've ever done it for use these I32s instead of int for loops and stuff because int's so common. But I say we just try it. It's our own project. If we end up not liking it, I don't know. It's just nice to have consistency, and nobody else has to care. Is that it? Are we not using any other types? That's cool. Nope. That was super easy. Okay. Maybe integers isn't the right word there, but do we care? Fixed width types, fixed width. Well, they are, I guess, because float's not using. Yeah, it doesn't matter. Minor. All right, let's move on to some bit more abstraction, get rid of some of this SDL stuff, and we'll slowly move it into its own package and hide the fact that any of it's SDL. So we're going to have like an OS layer that you can have SDL implement, our new OS that we'll build in the future, SDL3. If you put it on Linux, you could have X Windows implement it. You just have an implementation for your kind of for your OS slash platform. Um, and then for your implementation, it's basically for you to get a window up. How do I draw a pixel? And then everything else is abstracted from that. So we'll just start right here and we'll move things into files, but we need a display. I think we're going to need these three things. We're probably going to want width and height stored on the display. One thing is it makes sense, that seems like it would make sense, is to use U32s, like unsigned, for width and height in a lot of places. But if you do that, you end up having to cast all over the place and it starts to get annoying. I've just run into it so many times that now I just do some asserts early on to ensure that, these aren't negative and keep them as signed. And it just reduces the number of casts throughout. It's in a bunch of places where you need the width and the height, and it makes sense for them to be signed. We'll see later. We'll probably we won't run into it, but I'll point it out. Let's This will take an allocator at some point, but let's just do without it for right now. Um, we'll use calc here. I never remember if it's one, the count, then the size. Yeah, so we just want one. Let's just isolate this stuff. There's nothing else there. Later on, this actual type will be, you won't be able to see what do you call it? Oh, it'll be an opaque pointer because we don't want to obviously show any of the SDL specific stuff. Um, so that's why we always are going to pass it in explicitly. There's going to be no global or anything. And then here we can do all this and deallocate. And while we're here, I think we can just let's go ahead and do where was that? I think it was and then I think it might be nice to just have OS display present or something. What do I want to do? Because right now we're going to have um, so right now we're just going to manually have this OS here. Later we'll have an entire uh, Windows server that will create the display. But for now, let's just do this. And we'll also wrap SDL poll event with our own SDL, OS poll input or something like that. But then I kind of like this OS display present because this is called render present here. So we create, destroy, init shutdown, create, destroy. Let's put it in between because it's the order. Kind of do like init shutdown, create, destroy, and then the other ones for now. Present. That's kind of, I did turn off the snippets thing, but I think documentation is still popping up, as you can see there. Why isn't that working? Oh, pointer. All right. So later, both create and destroy will take they'll both take allocators. Anything that's going to allocate or free will take allocators. But what we're going to do now is, since this is OS, let's create kind of forcing us into the problem with the compile. With I mentioned earlier about the what am I trying to say? The pointing to peer files. I don't know why I'm so tired I can't speak anymore. Maybe I should, I should quit soon. But when compiling the relative path, wow, I do need to stop soon. Where are we? We want to make a directory called OS. And this is kind of cool because I think what we'll do is go os.h. I don't know why that didn't get created already. So this is the implementation code we don't want, but we do want this, this. And so this is all this implementation here is specific to SDL, right? So let's create another OS and we're just going to name it info for implementation. And we'll say SDL. I mean, is it Mac? Is it SDL? Let's just put SDL2 for now. And that is a C file. I don't even really think it needs os.h, but we are going to do it. And it can take all this. We're going to have to keep that now because we still have the event polling. What else does it need? Include assert. Okay, so and AK types. See how it can't find AK types? That is, we might just fix that right away. I am going to put -I source. I think that's all we're going to have to do. Then it will look relative to source, right? So we can do make clean. This is one of the few times that we need to do bare. And we can't, okay, well, we can't even do it because our code's actually currently broken. So, but I think it did work. So we'll do it type def. All right, how do we want to do this? We need to get our this. We're going to stick this in the implementation. I'm not even going to type def it. I'm going to call it OS display. And then we'll type def it to OS display T outside. Did I set? We just got tons of errors going on. I think that we can just now go os.h. Type def direct OS display to OS display T. Is that cool? Wait, init, shut down. You're going to need those with almost anything. We want to be able to create and destroy a display. In the future, it'd be more like a hardware display, like a frame buffer or something. For now, it's just going to be SDL, and then present. Like then that's just the whole all whatever the draw code is. Mm. Actually, no, it's going to also have to take the pixels. So yeah, because it'll have to, yeah, it'll need the pixels. Is this cleaned up now? Yeah, I bet it's going to complain. Pixels and complaining about the screen width, which is why we need a display width. What other errors do we got? Pixels. Okay. For now, I'm going to do something different. I'm going to have like a concept of a surface that's going to be pixels, width, height, maybe type. But for now, let's just pass in what it is. Just to make so we can compile and make sure stuff's working. All right, so that's good. What else is it complaining about? OS, what, os.h? So let's clean, just in case. Yeah, definitely, just in case. Oh, the make file isn't referencing the new, this bit. And this is actually going to, this is where it was going to force us into the relative path stuff, because the issue is we can do find, no, sorry. We can do shell and just run find here, actually find source, because we only want to look inside the source directory. Name all the C files. The problem is when it tries to create the object files, it's going to create them in the same directory structure. So right now, we're creating source manually, but we also now have an OS one, and we're going to have right away, we're going to have a graphics one, and it's going to start to get messy because, we're going to have to keep up with it. So I'm not sure if we should just brute force this, or what if we do this? OS, is this space separated? How do I do this? Can I don't know if I can just do this space separated. Let's try. And what did we say earlier? We're going to go ahead and just do that because it'll do that. I could probably do like a comma separated splat, but I don't I can't even think about how to do that right now. Let's see how this goes. How do I do that? Is there something else going on? I was just going to put them in modules so I could add them to the top. And then this would run here, and then this would run for one of each of the modules, but I don't think I'm probably doing something wrong. Yeah, then it's trying to go build AK, and I don't know how to do that. Can I need to be comma separated? Doesn't make any sense. Nah. Okay. All right, manually go. We'll fix it up later. These won't grow that fast. Like after we have just a handful of them, then we'll be good. But this is not cool and it bums me out. And it's just a manual thing. And this is where I always run into stuff around this time and make and end up switching to something else. One thing interesting to use that I've done recently in projects is use the Zig compiler, C compiler. You don't have to change your code or anything, but use the Zig compiler and the Zig build system. And it's a lot, at least to me, it's a lot cleaner. You get the run commands. You can do Zig build run, Zig build CPD for like the compile commands database, that JSON file we generate. But I don't know that I'm cool with all this early in the project, making the Zig compiler dependency. And I do think though in the future it might be cool to start using Zig for some stuff. That might be where we end up at Zig's at 0.15 ish right now. And there's tons of stuff moving around, and I don't really want to go building on it just yet. But I would like it, to remain an option. So it'd be cool. You could use the Zig build system and just have some files in C, some files in Zig. But let's let them stabilize while we're having fun here. Wait, so does this all even work? And it does, okay. Well, that is kind of cool because now this is our OS interface, like the platform layer. So anything we run on needs to implement these things. Nothing, and then because of the way this is, nothing can see the fields of the display struct. Oh, nothing can see the fields, so it's just an opaque pointer here. So nothing can reach in and mess with SDL, has to even care about SDL. And another problem with our makefile setup is right now it's including that implementation. In the future, we need to be more explicit because if there's two implementations, it's going to get them both. And there's going to be clashing symbols for each of those functions. So yeah, every day or every one of these videos are going to be a makefile, things that are pissing us off with a makefile. So we'll have to do something. All right, let's just go a little bit more. So we have our implementation. Let's look in here. We're going to need to get rid of this and create our own events. Like we want to abstract away all the SDL stuff. That one I might do offline just because you have to do like so much typing for each of the key types, the event types, the meta key types, the mouse. Like the whole event infrastructure is very repetitive because you're basically converting everything. You create your own types, and you have to create code to turn everything from SDL into your native types. It's really nice when you're done. And then if you implement it in a different OS, then everything, all the code's just abstracted away, and it's very nice. But it's pretty tedious and boring work. So I will do that probably in between this and the next video. But one thing we can do is improve this pixel stuff. I'm just trying to decide if I want to commit what we have already. Yes, I do. And extract majority of the SDL to, not the majority because a lot of it's input, some of the SDL to implementation. I'm not going to be too, that's really how we did it, right? Yeah, we're just moving code around. So now we want a new one called graphics. I thought about some of these prefixes before, and I've used similar things in the past. And they end up working pretty nice. So I'm kind of going to stick with what I like and what worked for me before, unless we run into anything. So let's. So this is our graphics. This is where we'll have like a surface, and all it is, a surface is just going to be essentially pixel array or a bitmap kind of with height and U32s. Later on, we could have different surface types, but for now, we'll just keep it simple. We don't need. You could have different types like the pixel layout, like we talked about earlier in the previous video, RGBA, ABGR. There's a million different pixel layouts. We're going to try to keep everything in our preferred style and have conversions to and from it. So, yeah. So for right now, we'll also have a color type. Instead of using U32, we'll do an RGBA struct that are U8. All of them are U8s, make it U32, and then we can pack and unpack those. I kind of like doing that. I don't know if there's a ton of value. I like the type. I like doing it. I don't know for like performance sensitive stuff if it's really that good. I think U32 throughout is probably better, but it's kind of more fun to have our own type. But let's get to it. What are we going to call this? Just data, maybe? Again, we're going to use signed instead of unsigned for the width and height. And These, yeah, we have to allocate. We got to allocate for these, and then pass them around. And all our draw functions and stuff like draw line, draw circle, draw rectangle, etc. will be here, but only like primitive stuff, higher level stuff like draw windows and panels and buttons. That'll be in a UI module, not in this graphics module. This is more low level um, primitives, I guess is the way to say it. We kind of have a module noun verb pattern, and we'll probably just stay consistent with that. This in the future, like we said, will have an allocator that will pass to these, to the create and destroy, but not right now. What am I doing? We're not going to hide the implementation like we did with the display. We want to be able to access the data from, maybe you want to hide it, but I don't think we're going to hide it at first because we don't have different implementations. You might want to hide it because you don't want people poking around, but you're going to need access to data. You could make helper methods, but this is C and we don't need a million helper methods. Clang format really likes to put the matching header first. And I can't remember exactly why. There's something that like proves that the header has all the includes it needs. And it's not depending on these includes or something like that. So, but it kind of annoys me because they're not in alphabetical order, but it also makes a little sense. We need to write our own assert here soon too. And I do kind of write for stuff like this, a fairly assert heavy code. I like stuff to just blow up as early as it can. This is an industrial code running cars and spaceships. Although they probably use a bunch of asserts during testing, but just to catch invariants, I think it's good. It makes me feel better about catching stuff early as possible when you're running through it. It takes 2 seconds to throw a couple of asserts at the top of a function. So we're going to do times height times size of U32. No, that's wrong. Sorry. But we are going to need that. We need to allocate for the whole thing. But surface data, it does need that. And we're going to assert surface. And we're going to assert surface data, because calc can always return null if it fails. Again, these are minor, but can catch little stuff one random day when we're working on things get passed through, and you're an unexpected null is getting passed through, and you're trying to free a null and let it, instead of letting stuff just be loosey goosey, just blow up. All right. So means this goes away. Yes. So we're going to have a surface and a display, but these both are going to be tucked into a Windows server later, or Windows service, or Windows server. I'm not sure yet. Let's name it desktop, maybe. No, screen. Let's just do surface for now. My LSP blown up. There. I don't know what that was. Instead of the global pixels, now we have a surface we pass in for everything. And we're going to move these. These now belong in graphics surface. And let's rename the functions to, so again, noun, verb. So this is a special case because draw, there's going to be a ton of draw functions. So I don't know if I want it graphics draw pixel, draw line, or graphics surface draw pixel, graphics surface draw. Like, is that too long? Let's let's defer for now and just draw a pixel. Let's just do that. I'm going to even move it to a new draw because this is going to be you. This is going to grow fast. Draw C. That looks good. That looks good. This surface clear though. That belongs in surface C for sure. Because that's not a draw function. That's just like a fundamental function of this thing, in my opinion, of a surface, you know. It's just fundamental to it, like create, destroy, clear. So here we can do, now we are going to have that function call overhead, but whatever. I'm going to test this pause functionality for a sec. Take a 2-second break. Oh, I hope that worked. Okay, let's keep going. I renamed that. Oh, yeah. So this got renamed project wide. So we just need to pass it the surface. Yeah, perfect. And then this, we could do a draw line here. But we're not. Let's just pay the overhead for drawing pixels to functional. Then we can come back and have the draw line. So this is going to be graphic surface, draw pixel on a surface, on the surface. And then it needs XY colored, right? Is that what we're doing? Yeah. XY color. Why am I going brain dead? So X is X, Y is 200. Yeah, I don't know why I'm overthinking it. Right. So 2, 3, 4. I'm actually gonna put these colors inside of graphics too. That makes sense. Right now they're defined because they're just swapping out ints, but when we have our own color type, it'll make more sense to be graphics color. This needs to be updated because it doesn't take pixels. This is just temporary. So we can do graphics, surface, surface, surface data. One thing we do want to do here, let's fix that real quick. Part. Is that what just happened? Sweet. For now, we definitely want to have a quick assert the display width is the same as the surface width. If not, do we want that? Yeah, because the display is always going to have the the surface needs to be the size of the full display, or it doesn't make sense. The reason I thought that is because does it make sense to pass in the surface width here? I mean, it's the same, but just semantically, the rect. What does it say? The area to update. Oh no, sorry. Wait, what? Update texture. Oh, what size? The pitch, number of bytes of pixel in a row of pixel data. So it is referencing the surface. So let's just, it doesn't matter, but I think it's better that way. And I'm trying to think if it ever could be different, but it's it's technically more proper that way. What do we got going on here? So then we can pass in surface here. Is that it? Are we good? Sweet. Escape doesn't work. Still need to fix that. So now we do have two new modules. OS and graphics are both going to grow. OS won't grow that much actually, except for the input portion. Um, yeah, input. But there's a decent amount in there. There's events and mouse movements and keys and um, return. Yeah, then building up our own custom event types and returning those and switching on those, and then passing stuff to the Windows server itself once we create that. Um, I'm trying to think if there's anything else we want to do before we wrap it up. I'm starting to make mistakes because I'm tired. So we got rid of all that. Basically just added the surface, the graphics module, and a surface type. Yeah. Sometimes I like to put that because it's not just code that hasn't been wired up yet. We're adding it and using it. Maybe I did it there. Not consistent there though, but it's fine. Is there anything else we want to do? We could fix or write our own assert real quick and move these to the graphics. Let's maybe do that. Graphics. And we can do it in a temporary way that's kind of good, I think. Let's just do color.h. We don't have a color type yet. We don't have to have one yet, but we can type def. U32 to graphics color T. It's kind of like an interim. Then we can do, can we just do static inline? Do we care? Not about inlining, but where don't have to do, we're not doing extern. Let's just try. And I don't know what's better, graphics. I like consistent prefix, but for things like colors, does this make sense? Wait, what? Am I tripping? Can I not do that? Oh, is that? I don't know if that's allowed. Do we like graphics black? That's just too long. And do we want it to be a constant? Like, nah, because it's not a macro. I think for now, this we'll figure it out later. Um, so let's just do static const graphics. Nice. I don't know if this is actually going to work, but let's try. Oh, did it work? Kind of. I mean, it looks like it is. Let's see if it actually compiles. I might get a linking error, but since it's static, I don't know that we're going to have a problem. Righteous. I love that. That was easy. Again, in the future, we'll have a different type. I think what we'll do is something like this. And I don't know. It's because sometimes you want to have access to the RGBA. Sometimes you can create helper methods for that. You can have a pack unpack thing, but the internal, like the internal representation that gets passed throughout the system is just a U32. But with compilers now, I don't know. This probably gets optimized so well that it doesn't even matter. That you're passing a struct by value. I mean, it's the same size. So let's not stress about it too much right now. So you can kind of see we're not seeing much. Oh, we're not destroying anything. I was going to say we don't see that much code that's not ours except for SDL event and poll event. Is that it? It's pretty close. OS display, destroy, display. But we should do surface too. This is where our debug memory allocator is really nice, because it would have caught this immediately and said, hey, you never freed this stuff. We track everything so we know if we didn't free stuff. It's quite a bit, well, I say slower. This is very simple code. The project's not that big. And it's not even a real, production code, so it doesn't matter. But it's nice knowing exactly where you're allocating and not freeing. You catch stuff, or at least I do. I miss stuff all the time, and it helps I really lean on it to find stuff for me. Let's just do these separate. And use graphics code. You know what? Do I prefer that? Like all the init code. Is OS like big enough to be separated on its own? No, let's just do init code like that. And destroy code like that. And the last thing we're gonna do is add our own asserts, I think. So we got a condition. And we're gonna do the classic, wrap it in a do while 0. How's it like that? There we go. This is the Clang format deal that we did. No. Align, escape, new lines. Yeah. That's why this is all nice and tidy like that instead of being all the way back over here and then back out. I'm a fan of that. So if not condition, wrap the condition, obviously. What? Macro suck. So if we don't have the condition, we're going to do a couple things. We got a kind of a nice way to do variable length args so we can add a message, a formatted message or not. But for the first pass, let's just keep it simple. Print f, dead air, insertion failed. Then you can put a string here and pass in con with that. So then it'll show the actual assertion just as a string. One sec. Assertion failed. Is that enough for now? Yeah. Yeah, we can make it. We'll make it better with line numbers and all that stuff. But let's just do this. And what are we going to do? What is it built? I feel like people use built-in unreachable, built-in trap. Maybe trap's better for debug. I think it will set a breakpoint if it hits in the debugger. I don't even. Are we even building in in debug right now? Are our certs even running? I don't know. Maybe we should run the standard assert that we know just assert false. Is this what we want? Assert pragma. For now, let's first run. Yeah, let's try it out. Main. Let's actually just try out and make sure our existing inserts are running. Yes. Oh, well, that's, I want our own, but that is almost exactly what I'm doing. And they're trapping, so that makes me feel like I am using theirs, right? That's not ours. That's, I mean, that's pretty close to what I want. But oh, I think it's because, yeah, you can't add a message in here. That's what we want to be able to add a message or leave it out. So we know our asserts are working, but let's get rid of assert. You can change any version of assert to assert. Is there none in here? We didn't even need that. We don't need that. I don't even think. Sorry, my dog's making noise. I think that. Well, we'll come back to that. I'm gonna no, make it. Why didn't it typically? It's just it's a little notes deal you can keep for later. Little to dos. And I lost track of asserts. So there are no asserts in here. Where do we have assert? Here. So let's take this out. Call to undeclared function built. Oh, misspelled built in. Instead error. We need. Okay. Should all be good now. So the value of this is that, well, the value of it is that we can also add a message if we want one and format it. With the normal assert, you can't, but we can even improve this. You know what we could do is if we wanted to be fancy, we could even steal their format, the original one, so it'll look really familiar. Assertion failed. What was the assertion? And okay, I want to do a string file string line digit. Actually, I'm not going to do it that way. I'm going to take all this out. This line's just getting stupid long. We just won't do a new line there. And then I think we can do just do a new one here. Does that do what we want? That's ours. That's pretty spot on. Function main. Let's just do it somewhere more fun. Like let's do it in, let's do it in the present layer. Function, where is file? Okay, I love that. That's great. And then what we can do is the final thing is just to add the optional, like the message and formatting. Main doesn't need that anymore. Everything works as is. Nothing's including the system assert.h. So what if so you can't have, there is a little bit of an issue here because you need to put vargs, but you can't have the comma there because it's got to be let a string be passed in. So I think I'm going to put I think I'm going to put the condition down here. We're going to have to try this out because I don't know if we're going to love this or not. And we actually don't need any of that because you put it right. You don't put a comma, you put it there. So when you pass a string, it just immediately concatenates with that. So we're not going to do anything, but we are going to test it with no message still. Let's just do something else to make sure we're not getting cached. So that's it. That message looks good. There's an extra space in there. Do we want that? Searching failed. Problem is there's a space here and here. But if there is a var args, you're going to want both of them. But if there isn't, I keep saying var args, but is it variable array of args, variable something? Um, if it's there, you're going to want both the spaces. If it's not there, you're not. So we might just tolerate that. It's just an assert function. So let's see. With a message, you can say 100 doesn't equal 99. This is one way to do it, which isn't that big a deal. Assertion failed. 100 doesn't equal 99. With our string, with that's great. But another thing you can do is you can actually format. Let's just do 2D. Oh, let's do that. 100. It's kind of stupid to do it as a float because. No, let's do it. Just to show that it works on multiple. Cool. I like it. Yep, and then there with no message. See here, though, when you do have a message, you have the space on either side of this, and you do want that space. And we could do some magic to add it, but I just don't think that it's worth the extra effort. So I think I'm just going to leave it as is. And then we'll use that assert a lot more places. I'm kind of maybe annoying about it. I like that tiger belly, tiger style, not tiger belly, tiger beetle, the Zig financial database company. They have that tiger style, and they have like to get rid of like spot invariance. They always do like a handful of asserts every function, and sometimes it feels like overkill. But I've used it in my own code quite a few times, and it definitely catches a random thing here or there to carry its weight. And I kind of think it's almost self-documenting in a way. When somebody comes in, we know what to expect. And yeah, so like places like this, do we really want to call this every time? I mean, I don't know, but like, do you want to have that in every function? Is it just ridiculously loud and annoying? I don't think it really is. Maybe null pointers like that is, but aren't there? Isn't that the $1 trillion mistake? So they don't really bother me. So we might run with them for now, and we need to get better at const on some of this stuff as we go forward. Kind of come up with a pattern. I think I'll do const on struct pointers coming in, just so you know, to not get modified. I think doing const on local variables is like int a equals 0. Doing that const is a little noisy for me. I don't know if that's really ever caught anything. And then obviously, if it's not a pointer, it doesn't need to be const. It's a copy on a parameter. So probably keep const pretty, not completely minimal, but where it actually is going to make a significant difference. All right, I'm jabbered on now. Assert's done. One last check that we're not using assert. Nope. So is that all we did? We don't want to include assert here. We don't want to do that. We need to decide standard lib, does this stuff or the standard includes, should they come above? The reason I don't is because of this .h. They always force it to be the top on the format, the claim formatter. So, all right, that's it. I think I'll deep dive on the allocators just so I really understand it before I go write it, and we'll come back and do that. And Windows Server, um, the Windows Server part's kind of cool because then you start getting Windows and the Windows Server, and we can do events dragging it around. And in the meantime, I'll do the input stuff that's real tedious between this and the next video. Have a good one. Peace.